Hey everybody, Dave Limburg with another episode of THD Podcast. On this week's episode, we have Tim Brault joining us from East Coast USA, and he's going to talk about DBX-TV, and they're a company that provides signal processing solutions to make your less than optimal speakers in your consumer products sound that much better. So they have all kinds of signal processing solutions that help enhance the audio in your TVs, speakers, and all kinds of different areas. But without delay, let's thank our sponsor, the Alti Association. So we encourage everybody to get out and join Alti. Alti's mission is to promote and advance the interests of loudspeakers and related audio technologies for the benefits of their members and the industry at large. So without delay, let's get into the podcast and learn more about DBX.
So Simon, how are you doing? You're in Japan again?
Yep, and as usual, haven't moved.
And Tim, joining us from outside the Boston area. How are you doing this evening, Tim?
I'm doing great. Thank you very much for having me. It's a pleasure to be on the podcast.
All right, great. Yeah, so I always give people a very nebulous introduction to what's coming up, but maybe you want to jump in and tell people about DBX-TV.
Sure. So we're a audio technology provider that focuses on improving the sound of consumer electronics. So we primarily started in televisions and have more recently been branching out to home speakers, portable speakers, things of that nature.
Okay. And historically, there was a connection to the processing on the guitar pedals. Is that correct?
Yeah, actually, maybe I addressed that in the presentation, so maybe we could hop right into that, and I can give you some more detail.
Great. Yeah, let's go for it.
So, you asked about the company introduction, so perfect place to start here. DBX-TV is a provider of effective, efficient, and easy-to-use software that improves the sound of televisions, soundbars, smart speakers, and other devices. And we're a division of that corporation. So that corporation started as part of the breakup of DBX Inc. The various divisions got split apart. One went with AKG and eventually Harman. So the DBX Pro line is all still owned by Harman. And one of the divisions was an integrated circuit division. Some of the management of that division bought themselves out essentially from DBX Inc. and were able to continue supplying their largest customer, which was then DBX Pro and Harman, but now a separate company. So that corporation started back in the early 80s as a result of that. And they eventually were reunited with some of the engineers and the patents for the DBX noise reduction standard that was used in the BTSC system in North and South America. So that's the kind of the tie together between what was DBX Inc. splitting to various different divisions, and one of them becomes that corporation. They get reunited with DBX-TV, and here we are under the one roof. So there's three parts of that corporation. The Pro Audio integrated circuits. They also have a silicon foundry in Silicon Valley that focuses on primarily Pro Audio, but some other niche applications as well, all analog. And then the DBX-TV IP licensing division.
And when you're saying that corporation, just for people's reference, that's the name of the corporation is that corporation. It's not...
Yes, it is. THAT. That's an acronym for the founders, Tyler, Hebert, and Travellini.
Okay, cool.
Yeah. Makes it a little complicated with Google sometimes, but know, in the early 80s, that wasn't exactly a concern.
Right. Okay.
Yeah, so we recently received a couple awards just for additional background. Back in the 80s, there was the Emmy Award for the BTSC noise reduction standard, and then More recently at CES, we got the Innovation Awards and Twice Picks Awards for our Total Cal in-home tuning system, which I can get into in quite a bit more detail later on.
Okay.
So as I mentioned, that corporation is the Pro division. We're supplying a lot of the familiar manufacturers that I'm sure you're aware of in live, broadcast, studio, also more recently in cameras. So it's you're finding our chips all over the industry. And then on the DBX-TV IP licensing side, we're working with a lot of the main ODM manufacturers in Asia and partnering with over 100 different brands throughout the world.
Mm-hmm.
So the main issue that we're trying to solve is making it easier to get good sound from consumer devices, which is really tricky, especially in televisions where we started off. But it's really the same principles ringing through to sound bars and smaller speakers as well. And the real issue is that you've got small, inexpensive drivers usually with a pretty difficult frequency response. They can't play all very loud before they start to distort. When they have quite a bit of distortion, and you're also often using a single driver to cover the entire frequency range. So it's a tough challenge for manufacturers to get good sound out of this.
Mm-hmm.
It's also difficult, especially in TVs, to deal with the speaker placement. They're usually facing down or backward, which obviously doesn't exactly give you a great stereo image.
Mm-hmm.
But there's cosmetic considerations at play that the manufacturers have no choice but to deal with. And then there's also a consistent complaint and problem with loudness with source material and switching input sources. So everyone's familiar with the too loud commercial.
Yeah.
And probably equally familiar with the idea of a sleeping baby in the next room, which actually I'm dealing with now. And I wouldn't want to play, some whispered dialogue followed by a huge explosion, which would wake her up and cause a whole bunch of commotion.
Mm-hmm.
And this is, if anything, just been exacerbated in the digital age. It was supposed to get better, but has really gotten worse in some ways, especially with streaming platforms, as they just they don't really have any of the same regulations or as broadcasters do, but they have all the same incentives to make advertising louder than the program. So that amateur produced content, you name it, there's a lot of different reasons why loudness can be really inconsistent. And the best place to control that is in the home.
Okay.
So things that manufacturers have to do and that we try to help them do is control loudness, correct the frequency response of the speakers, and make sure that there's a stable and realistic stereo image. And the way we do that is with our Total Technology post-processing suite. The core of Total Technology is Total Sonics. This is a combination of equalization, stereo expansion, and dynamic range control, and dynamic EQ to help boost bass without overloading or distorting the speaker. We've got Total Volume, our loudness control solution, which is kind of a multi-band implementation of DBX style compression and is modeled after the old style DBX compressors with their RMS-based attack.
Mm-hmm.
Total Surround is our virtual surround sound algorithm to extend the stereo field beyond the confines of the TV screen and give the perception of the sound coming to the sides and to the rear just from two speakers. And all this is controlled by a system called Total Cal Pro. And this is an intelligent controller for Total Technology that consists of a PC and some proprietary software, measurement microphones, and an audio interface. And we deliver this to our licensees. And it's really an automated tuning system. that measures the TV or speaker, is able to detect the frequency response, measure the harmonic distortion and distortion onset point, and customize all the parameters of Total technology to match that speaker and amplifier. So it's really every implementation of Total technology is tuned by Total Cal Pro. So they really are customized every single time.
Okay.
So all of this working together is designed to deliver the best possible sound from TVs, soundbars, home speakers. We've recently been testing the algorithms on tablets and mobile devices, and it works very well with that as well. And really any consumer device with a speaker, we can usually make it sound better.
Okay.
So I can get into a little bit more detail about the solutions and kind of how they all work. So with loudness problems, this is an example with some measurements that we took using a LKFS unit. And you can see on the left, you've got kind of some whispered dialogue followed by a really loud commercial. In the center, you've got one already loud program going to an even louder commercial. And then on the right, you've got that example I was talking about. It's actually Mission Impossible 2. There's a scene where there's some whispered dialogue, and then boom, huge explosion. And you can see there's about a 25 dB dynamic range difference there in loudness units. That's pretty extreme. And that's great for a home theater sometimes. It's definitely great in a movie theater, but there's other times where that would be totally inappropriate and just doesn't work to disturb the neighbors next door with the thin walls. So control of this really needs to be in the hands of the customer, I think, for this to make for loudness control to make sense. Okay. The way that we took those measurements was using the ITUR BTS 1773 standard for LKFS units. And the gist of this being that all of the channels are weighted. We take the mean square of that and sum them, then get a logarithmic measure of perceived loudness. Okay. So in this case, we're looking at the two-channel sum of the 5.1 downmix. All right. So when we measured this for an AES paper a few years ago, we did over 1,800 channel changes and found that about a quarter of them had pretty extreme loudness variations of up to 29 dB, which is just crazy. That's a huge jump. So then obviously if it's happening a quarter of the time, that's pretty extreme. And I mentioned
Tim,
that
what does that mean, channel changes?
Oh, sure. So in this case, we programmed a remote blaster to change the channel, in this case, cable broadcast.
Oh, okay, TV channels, sure.
Right. Changing TV channels, and just measured a couple seconds of each, changed it, moved to the next, and we just integrated the loudness over time.
Interesting. I think everybody can relate to this scenario.
Yeah, for sure.
A universal problem.
Yeah. So here in the States, they actually tried to pass legislation, and they did pass legislation to try to control this because there were so many complaints. But it doesn't really work because the rules don't apply to streaming content, and that doesn't really help anything when you're switching from your cable box to an Xbox to an iPod or a phone over Bluetooth. There's just there's way too many areas where loudness problems can still happen. So this really needs to be controlled in the home with a playback device, and needs to be processor efficient and be really transparent sounding. So that's what we're able to provide with Total Volume. So you can see on the bottom we've got the before on the top, the bottom on the after. Starting from the bottom left, There's still, I think, a natural variation in between, in this case, some quiet dialogue followed by wrestling, professional wrestling. But you can see the overall loudness is quite a bit more controlled. Same with the image in the bottom center. You've got a pretty consistent loudness across those two already over-spec pieces of program material. And then all the way on the right, you can see that the loudness is controlled between the whispered dialogue and the huge explosion.
All right.
So the real challenge, I guess, is not making the sound quality worse.
Yeah, for sure. It definitely needs to be transparent, and to well, I could put it this way: it works well and works best that you're not hearing it at all. You should be able to forget that total volume is on, and if you just want a consistent loudness, say for a bedroom television or something like that, turn it on and you'll forget that it's on, and that's a good thing because the loudness is controlled and there's no pumping artifacts or anything that would remind you that you've switched in a compressor.
Right, pumping artifacts.
Yeah, we've worked very hard and done a lot of testing to make sure that this is really transparent and artifact free, and that RMS style compression does a really nice job of responding to input level quickly, but with a pretty natural sound quality.
Okay. Would this be possible to be implemented on like headphones for like noise limiting headphones where you're concerned about maximum decibel levels on a headphone type product?
Yeah, I don't see why not. We haven't really focused much on headphones with our development so far, but I know that there's a lot of overlap with the chip manufacturers that sell into sound bars and headphones and other various consumer electronics. Yeah, I really don't see why not. I think it'd be pretty straightforward to implement it that way.
Okay, interesting.
So I'll get into a little bit more about the Total Cal Pro system now, the automated controller. So we use Total Cal Pro to measure speaker response. And as I mentioned before, it's usually pretty typical to have a really narrow and jagged frequency response, especially from smaller speakers. So in Total Cal Pro, we implemented a genetic AI EQ algorithm that was expanding upon the work that our founder, Les Tyler, did back with DBX Incorporated, where he invented the first audio equalization system. So we've kind of taken that one step beyond and are using a AI EQ algorithm to first suggest a target frequency response based on the measured speaker response, and then automatically calculate the corrective EQ response curve. So the first step of that process is, say if you have a speaker that rolls off at 200 hertz and you want to get something that kind of sounds like bass out of it, you might need to do a little bit of boosting above that frequency. But if you were to try to use that same response curve on a speaker that plays down to 60 hertz, it would sound really muddy and terrible, because there's just too much low mid for a speaker of that capability. So by kind of doing a lot of manual tuning over time, we've come to figure out what works for speakers of different performance levels to make them subjectively pleasing. And we've built that intelligence into the Total Cal Pro system. So this is also an area, though, where the manufacturer can put their own frequency response target in as well. So it could just as easily be flat or a typical kind of smile curve or or anything. So there's a lot of flexibility there where it can either be fully automated, or you can also put in a lot of manual input and tuning to get the result that you're looking for.
Okay.
So that's the point there. This automated target frequency response is that it's not you choose the best frequency response no matter what. It has to take into account the capabilities of the speaker you're dealing with.
Exactly. Right.
Interesting.
So the some of the real magic in the interaction with Total Cal Pro and Total Technology is the way that it configures Total Sonics, which is really the core of the audio processing algorithm. So we use a dynamic EQ system here where Total Cal Pro can measure the low frequency response and the harmonic distortion to find the point of distortion speaker overload. And by making that measurement, we're able to calibrate the dynamic EQ of Total Sonics so it can boost bass and extend the frequency response at as much as is possible given the speaker and amplifier, and dynamically given both the input signal and the level of the device. So this gives a lot of flexibility where, for some applications, you want to have as flat a frequency response as possible, and you really wouldn't want to have different thresholds for a multi-band compressor. You'd want to keep a consistent frequency response no matter what, even if that means you sacrifice perhaps some loudness or maximum output level. And it could also be kind of configured the other way, where we're able to, as the volume level of the system goes up, we can tame the bass frequencies and allow higher frequencies to keep going up and level. So you can get a very loud output with just as much bass as the speaker can handle before it overloads. So it's really flexible, and having that kind of control allows for a lot of ability to tune the speaker for the target application, really. But again, we can also just fully automate it and say, all right, we've chosen, again through a lot of experience, what harmonic distortion we think is acceptable for a certain kind of speaker, and what's typically audible to a consumer, and what's it almost gets into what's objectionable distortion, or which is very subjective, but you can kind of get some trends out of that after doing a lot of digging and tuning different systems. So we've kind of figured out our special sauce to take the objective measurements and make something subjectively pleasing out of it.
Okay.
Another really interesting part of the Total Sonic system is correcting the stereo image, which is especially important for televisions and things that are connected to TVs like soundbars. So the speaker placement usually makes for a really narrow stereo image. And there's another problem where you can have multiple layers of spatial enhancement kind of adding on top of each other and conflicting, which can increase loudness problems. It can actually make all of that stuff we were talking about before even worse, make the dialogue less easy to hear, and destabilize the stereo field. And that can happen when if you have some spatial processing done during the mixing, then done perhaps during the local rebroadcast, and then another layer of spatial enhancement done in the device itself. So that can affect some competing solutions, but we have a patent on an algorithm that measures the difference between the dialogue and the effects, and corrects any imbalances that were caused by previous processing. So we kind of make sure that the balance between the sound bed and the dialogue is where it needs to be. And once we do that, then it's safe to expand the stereo image, because it's not going to be so variable based on those multiple layers of processing.
And now
So
is that done just by isolating, like knowing the frequencies of like where the voice is at and where the effects are at? Or like how do you distinguish from the source track, and then if it's been processed and
it's partially based on an MS dynamic range measurement.
Okay.
So of course the dialogue is predominantly centered, and effects are predominantly or at least certainly not as centered as the dialogue. So by monitoring that and ensuring a stable MS balance, then you can do some 2-channel stereo expansion, and it's not going to mess things up because you've got a consistent input to it at that point.
Okay.
So those things working together solve the problems that make it difficult for manufacturers to deliver good audio quality in consumer devices. Controls the loudness, corrects the frequency response, and make sure that there's a stable and improved stereo image.
All right.
So then, that kind of summarizes the total technology, our core, and the product that we've had in the market for about a decade now. And just in the last year or two, we've come out with some really interesting new algorithms that are kind of trying to work on more complex audio problems in consumer devices. So we found that for consumers, immersive audio can be expensive and complex. I think, of course, there's definitely a case for that in high-end separates, and certainly not here to argue against that. But that is also not the typical big box retail consumer. And for immersive audio to really take off the way that it should, it's got to be democratized and easy for people to access and enjoy. So that's something we've been working on. We're trying to get the perception of even more bass out of really, really small speaker drivers, and also working on solving some problems with room acoustics affecting fidelity and sound quality. So with the immersive audio issues for consumers, it really starts actually on the pro side with creators. It can be difficult to produce immersive audio. We got to upgrade your production facilities. Especially in the developing world, there's still a lot of stereo broadcast facilities, and you can't put most immersive audio formats through stereo broadcast facilities. So that's a pretty big problem. And it's expensive to get the licenses and tools for immersive audio creators. It's also expensive for manufacturers because the decoder licenses are expensive. And we found that a lot of the competitive immersive audio solutions don't really provide a lot of benefit on 2-channel devices. This results in it being difficult for a lot of consumers to get into immersive audio. Because it's more expensive to make and distribute content, there's less of it, and you have to pay more for it. I know here in the States, the Netflix plan that supports Atmos is more expensive. So you're paying more for it every month, never mind just the equipment that you put into your home. And again, a lot of consumers can have difficulty configuring discrete systems. They're more expensive. And systems that use metadata for the object placement can be interrupted by VPNs or slow network connections. And then there's a good fallback to which then brings you back to traditional 5.1 if that happens. But okay, so then you're back to surround sound, and you're not enjoying immersive audio anymore.
Right.
So these are some shortcomings that make it difficult to, for the everyman to get into immersive audio.
Mm-hmm.
So we saw an article in Digital Trends a couple of years ago that was outlining for consumers how to make sure that they're getting Atmos sound. And I know I've been talking a lot already, so I'm not going to go through every point here.
It kind of makes a joke out of it. Like the average user is not going to do past step 2 or 3 here.
Right. And
it's almost says you can skip to probably not.
Right. And, to be totally fair and transparent, I followed the flow chart. I've got a nice Atmos home theater set up at home, and it's great. I'm not here to knock on Atmos, but this is tough for the everyman consumer.
Mm-hmm.
So our solution for that is total immersion, and we developed this in conjunction with the audio research team at Sykes Audio, and this algorithm generates the sensation of height on 2-channel TV soundbars and speakers. So what makes this unique is that it's designed for 2-channel audio systems and is compatible with any audio decoder. So the way that works is because we're working on a 2-channel down mix, we really don't, we're kind of agnostic about what processor was or what decoder was further up the stream. So, we're working on a stereo, just 2-channel feed. So whether that comes from a 5.1 decoder, Atmos decoder, DTSX decoder, by the time it gets to us, it really doesn't matter. And total immersion is able to, in a sense, unwrap the down mix, extract the height elements, and then render them through a virtual height process to get the first isolate and then present the height objects that the helicopter overhead or the rain and thunder, that sort of stuff. So we're able to, in a sense, kind of look into the mix, figure out what's supposed to be height, and then render that. And by doing it that way, it works on any source. So we can do this even going back to a vinyl record or a VHS tape, but maybe more relevant to today's world on a low bit rate compressed audio stream. We can still get immersive audio with height out of that. And there are some pretty interesting applications for that. I recall seeing a review of a prominent home speaker manufacturer recently that was touting how great their Atmos system sounds, except for when you use Bluetooth, because then it doesn't work. And that's a pretty big except, because a lot of people use Bluetooth.
Yeah.
So to really be able to deliver immersive audio all the time, it needs to be able to work also with a 2-channel input. So that's kind of the magic of total immersion, is that whether the original source is stereo or 5.1 or object encoded immersive audio, we're working on the stereo down mix, and really doesn't matter what the source material was encoded as, it'll just always work.
All right.
So then in comparison, the flow chart here for consumers is really easy. You turn it on and it's working. There's really not a lot to think about. Makes it very, very simple.
Yeah, there's historically there's been so many instances of this kind of like user like rear speakers. Like most people in a 5.1, most people don't connect their rear speakers. It's just the way it is.
Yeah.
So, asking them to follow that previous flow chart is absurd.
Right. Yeah, exactly. I mean, there's definitely a place for that, and I put plenty of time into my home system. But we're tweaky audio people. We're not representative of the average shopper.
Exactly.
So I mentioned one of the other challenges we were working on is trying to get bass from the smallest of speakers, and we found that especially in televisions, but also in some of the smaller devices we've been working on recently, like tablets, the low frequency roll off could be at 200 hertz or maybe even higher than that. And there's just physical design restrictions and cost considerations that make it so you just can't really get around that. And the dynamic EQ algorithm I mentioned earlier in Total Sonics can extend the frequency response, but really only to a point. You can only go so low before you're just introducing more distortion and not making things sound better. So there's definitely the possibility of too much of a good thing there. So Total Sonics is still kind of bounded by the laws of physics. We can dynamically extend the frequency response when that's possible, but sometimes it's not possible. So as a result, you have to filter out the lowest frequencies in the content to prevent speaker overload, and you lose that content. So that's a sacrifice that we weren't really willing to make. So we worked on an algorithm called Total Bass, and this is a psychoacoustic bass enhancement algorithm that identifies the frequencies that are too low for the device to handle, and then renders them in a range that the speaker can reproduce. So this is loosely based on the missing fundamental phenomena that has, of course, been around in the audio industry for a long time now, but we've put our own spin on that, found some interesting and efficient ways to do natural harmonics generation that still enables it to fit into the small and inexpensive chips that go into value-priced televisions and speakers. Because we're always focused on finding solutions that are affordable and can be implemented. With unlimited processing power, there's a lot of stuff that sounds really, really good, but that's not going to work for a $400 television. There isn't unlimited processing power, so you got to find ways to do things efficiently, and generating a convincing pattern of harmonics to trick the brain into hearing bass frequencies that aren't actually there is a tough challenge, but one that we've taken on and has resulted in the Total Bass algorithm. And one of the things that kind of differentiates Total Bass is the way that it pairs with Total Sonics. So we use the dynamic EQ that I've talked about before to extend the electroacoustic frequency response as low as possible without introducing too much distortion. Then once that's done, then we additionally use the psychoacoustic bass extension to extend the perceived low frequency response. So of course, if you go looking for 100 hertz or 60 hertz from a speaker that can't reproduce it, you won't find that with a measurement microphone. But perceptually, you can hear those sounds being rendered through the harmonics in a way that makes your brain think you are hearing a frequency that isn't actually there.
Mm-hmm.
So it's kind of the 1-2 combination that really makes this work so well, is rather than only relying on the harmonics generation to get a perception of bass, we get as much real bass out of the speaker as you can first. And then you can use the missing fundamental approach to get even more out of it from there.
Okay.
And then the last big challenge we've been working on is how to address some room acoustics issues that cause the devices not to sound as good as they did when they were designed. So both device placement, but also manufacturing variances can cause products to not sound the way that were intended when they were originally designed. And of course, having room modes and reflections caused by the construction of the room can create interference, cause uneven frequency response, unclear dialogue, and just overall not hearing the content as intended. Obviously, the best way to deal with this is putting up a lot of absorptive material and a beautiful diffuser in the back of the room, which consumers aren't going to do. So you got to find another way to deal with that problem. So, of course, digital room correction can help fix this, and digital room correction has been around in the consumer audio industry for quite a long time now. But there's also, again, problems for the average consumer to access that. For value-priced devices, the chip that's running them isn't really powerful enough to run a room correction process natively. So you can implement a standalone DSP and run some more processor-hungry calculations, but that's going to drive up the cost of the device or make it so that you can only get room correction in an AV receiver or something else that's got a pretty hefty price tag. Another thing that contributes to that is the need for the microphone. If you've got a dedicated wired mic, that drives up the bill of materials even more. Not going to fly with a television. The margins are too thin, so that's already out the window. You can use a microphone in a remote control or a cell phone to get around the problem of having to ship a wired mic, but there's a lot of variance in the microphone specifications that go into different cell phones, and who knows how many different cell phone models there are in the world at this point. So that's kind of a challenge. And then a lot of devices don't really have a display, which can make it a little bit difficult for consumers to use if they're not familiar with that kind of audio equipment. So the way that we've gotten around all of that is by moving the processor intensive functions off to a cloud server, and then using the user's, the consumer's cell phone or smart TV as the user interface to run the whole system. So that's our Total Cal system that was the CS Innovation Awards and Twice Picks Award winner this year. The Total Cal system measures the device's performance in the home and retunes total technology to compensate for room acoustics issues. And the way that we do that is because we have a measurement of the device with the Total Cal Pro system that the manufacturer applied during the device's design cycle, we know what the target frequency response is for that device and what the reference speaker response is for the prototype that was used for the design. So by comparing the measurement we take with the Total Cal Pro system at the manufacturer site and using that as the reference to compare against the measurement we take in the home with the cell phone. After you correct the cell phone's mic, whatever difference is left over is either there because of a room acoustics issue or because of a manufacturing tolerance issue. So then we can correct it back to the original target that the designer chose and make sure that the sound quality is consistent in every home that the device is shipped into.
Okay.
So we had to do a lot of engineering work to figure out how to make all this work. We had to figure out how to do a clock sync between the source device and the measurement device to get an accurate impulse response. Applied for a patent on that, and that lets us use a cell phone mic to get an accurate measurement that way. And we've also developed an algorithm to correct the variability in measurement microphones. So as I mentioned, there's countless cell phone models out there, and we're going to model the microphones for the top selling devices. But there's way too many legacy devices and new ones that'll come out, and we can only measure them so quickly. So we've been challenged by some of the manufacturers we've shown this to say, well, what happens when it's an older model cell phone or when a new model cell phone comes out? There's 100 different Android phones. How are you going to deal with this? So we've developed a method to take a near field measurement and generate a corrective EQ for the cell phone's microphone first. So then once the cell phone's microphone is flattened out with equalization, then we can use that to get an accurate measurement of the frequency response at the listening position. And one other kind of interesting challenge we had to figure out was how to stitch together a corrective EQ curve only within the bandwidth that the measurement microphone can support. So cell phones, they've got wide bandwidth mics for the most part at this point, so it's not so much of an issue. But if you were going to use, say, the voice control microphone in a TV remote, those may have 16 or even lower than that kilohertz sample rate. And then just the usable frequency response of the microphone itself can be limited. So we can, again, model that remote control microphone and correct for the frequency response issues to a point. But the bandwidth is the bandwidth, especially if you're dealing with a low sample rate. So depending on the what kind of a microphone and what kind of a measurement is available, we can accept measurements of different sample rates, and within the bandwidth that the microphone supports, we can make sure we're only doing corrective EQ within that bandwidth.
All right.
And this kind of gives a kind of an interesting peek behind the scenes to consumers, and if the manufacturers that implement this system decide to show this, but we can provide data about the audio system and kind of show the customer that that something has been done. So in this case, with the in-home measurement, we're able to display the red curve is the speaker response that's measured in the home. The yellow curve is the frequency response that was measured with the reference unit at the manufacturer site and stored with the Total Cal Pro system. So that information is stored on the cloud server and pulled down when we do an in-home tuning. Then we've also got the green curve is showing the target frequency response that was used by the manufacturer during the design. So then we correct the red curve to the speaker response as measured in the home to match the green curve, the target curve, as closely as possible. So you can see in this case, the result is the blue curve there, which hugs the green curve, the target frequency response, pretty closely. So the system can be used to tune everything flat. That's definitely something that can be done if that's what the manufacturer is looking for. But manufacturers have their own sound, and as I said before, given what the speaker itself is capable of, sometimes for consumers, flat isn't really the best or most exciting answer. So really, whatever the designer or the engineer had in mind when they put the device out into the market, we're able to recorrect to get back to their target in the home.
All right.
So yeah, that's those are the new things that we've been working on. To just do a quick recap, Total Sonics is really the core of Total Technology with the dynamic EQ, stereo expansion, and dynamic range control, and we've just extended that to a 2.1 version with dedicated subwoofer channel processing. Total Surround and Total Volume come in the Total Technology package to give a virtual surround sound experience and control loudness jumps. Total Cal, the home version, does in-home tuning to correct the frequency response of the device back to the original target. Total Immersion makes immersive audio easy for everyone by presenting height from 2-channel systems, regardless of the input source. And Total Bass to trick the brain into hearing low-frequency sounds that the speaker itself can't physically reproduce.
All right. Now, do you co-brand this? So would this be a logo that people? I think I don't get access to the Best Buys and such living over in Asia, but is this on the box? Like, how do you market it? How do people know that they're getting this in their product? Is it like a Intel Inside type strategy where you're on the box, or how does it work?
Yeah, exactly. Yeah. So our manufacturing partners can promote either the DBX-TV or the Total Sonics trademarks to end customers. Those are the two main marks. We promote Total Sonics more in the speaker business because the DBX-TV tie-in kind of doesn't make as much sense if it's like a Bluetooth speaker.
Okay.
But depending on the application, the manufacturers have the option to push one of those two as the main marks that go out to consumers, and then these kind of sub trademarks are used for the B2B marketing to help the product designers and engineers understand what the different algorithms are and what they're receiving.
Sure. Okay.
And what form is it actually delivered in? Are you providing a DSP chip, or it's software that the manufacturer puts on their preferred chip?
Yeah, it's all software, and yes, that's right. The manufacturer has their preference of chips, and we make sure to keep all of this really processor efficient, so it does fit into the vast majority of SoCs used for even really low cost televisions and Bluetooth SoC centered sound bars and portable speakers, things like that. So we really want to even make sure that the devices on the value end of the spectrum still sound as good as they can. Someone's got to pay attention to that and make sure that that the sound quality is as good as it can be, because by the numbers, that's how most people are listening to everybody's mixes and productions.
Okay.
You kind of asked the question I was just about to answer, Simon. It's efficient code that goes into even low-end SOCs and DSPs. The Total Cal Pro tuning system helps make it easy for the engineers and designers to get a good sounding result really quickly. We've got competitive royalty rates that make it reasonable for this to be implemented even in value-targeted devices. And altogether, Total Sonics, Total Immersion, and Total Cal are making technologies that used to only be available at the really high end accessible to the average consumer. And that's really what we're focused on doing, is making sure everybody gets to have good audio.
All right.
Thank you.
Yeah, my pleasure. Any other questions I can answer for you guys?
I think it's pretty comprehensive. Do you have any questions, Simon?
No, we've covered plenty, I think.
Yeah, no, it's in summary, I guess it's like this perennial problem with cheap TV speakers. Just not to be kind of rude to the TV manufacturers, but there's zero margins in TVs. It's such a volume game, and then they're still trying to have good audio in a TV. It's super challenging. I've done a few projects with TVs, and it's always space constrained and budget constrained, and it's near impossible to come up with a good product in the end. So
yeah, it's a big challenge, and our philosophy is just to meet the manufacturers where they're at. The better speaker drivers that they can put in, of course, the better the final result's going to be. But we kind of approach it as we take the system for what it is and just make it sound as good as it can. Who am I to tell a manufacturer that they should be spending more money on their drivers? They know what the price point is. They know what their market is. They have a lot of different considerations, like you said. So it's our job to take what we're given and make it sound as good as it can.
Okay. Well, I guess if there's no more questions, Tim, thanks for joining us today. We appreciate your time. Appreciate the explanation on your products. And anybody is interested, you get a hold of Tim via these channels on the screen right now. And please like, subscribe, share all that good stuff for the YouTube and Spotify and all wherever you're watching this today. So once again, thanks, Tim, and we'll see everybody on the next episode.
Yeah, thank you very much, guys.
Okay, bye-bye.